Download this code from codegive.com, link in the description below. OK, let's dive into the world of API rate limiting. This is a crucial aspect of API design and management, ensuring fairness, stability, and security for your service and its users. We'll explore 7 best practices, providing detailed explanations and code examples in Python to illustrate the concepts. Why rate limiting matters. Before we begin, let's quickly recap why rate limiting is so important. Protecting resources. APIs have limited resources, compute, memory, bandwidth. Rate limiting prevents a single user or application from overwhelming your infrastructure with too many requests, which could degrade service for everyone else. Fair usage. It ensures that all users get a fair share of your API resources. Without rate limits, one heavy user could monopolize the API, making it unusable for others. Security. Rate limits can help mitigate denial of service, DOS, attacks. By limiting the number of requests from a single source, you can make it more difficult for attackers to flood your system. Cost management. If you're using cloud-based APIs, example AWS, Google Cloud, Azure, rate limiting can help you control your costs by preventing accidental or malicious overuse of API resources. Business objectives. You can use rate limits to monetize your API. For example, you might offer different tiers of service with different rate limits based on subscription level. Best practices for API rate limiting. Here are 7 key practices you should consider when implementing rate limiting in your APIs. 1. Choose the right rate limiting algorithm. There are several rate limiting algorithms, each with its strengths and weaknesses. Choosing the appropriate one depends on your specific needs and how you want to control API access. Token bucket. Concept. A conceptual bucket holds tokens. Each API request consumes a token. The bucket refills at a certain rate. If the bucket is empty, the request is rejected, or queued, depending on the implementation. Pros. Handles bursts of traffic well, up to the bucket capacity. Smooths out traffic over time. Cons. Can be slightly more complex to implement than simpler algorithms. Use cases. Good for general purpose rate limiting, especially when you want to allow some burstiness. Leaky bucket. Concept. API requests are added to a bucket. The bucket leaks, processes, requests at a constant rate. If the bucket is full, new requests are rejected. Pros. Very simple to implement. Guarantees a consistent processing rate. Cons. Doesn't handle bursts well. Requests can be dropped even if the system isn't fully loaded. Use cases. Suitable when you need to strictly control the output rate, such as in streaming applications. Fixed window counter. Concept. The time is divided into fixed size windows, example 1 minute. For each window, you count the number of requests. If the count exceeds the limit, requests are rejected until the next window. Pros. Easy to understand and implement. Cons. Can allow twice the rate limit if requests cluster around the window boundary. Use cases. Simple rate limiting where absolute accuracy isn't critical. Sliding window counter. Concept. Similar to the fixed window, but instead of using fixed windows, it tracks requests over a sliding window. This means you're always looking at the last n seconds/minutes. It's a smoother version of fixed window algorithm. Pros. More accurate than fixed window counter, avoids boundary issues. Asterisk cons asterisk more complex than fixed window counter. Asterisk use cases asterisk API rate limiting where you need a more accurate traffic control. Asterisk sliding log asterisk. Asterisk concept asterisk you keep a log of timestamps for each request within a window. To check if a new request is allowed, you count the number of requests in the log within the current time window. Asterisk pros asterisk extremely accurate. No boundary issues. Asterisk cons asterisk can be resource intensive to store and process the log, especially with high traffic. Asterisk use cases asterisk scenarios where precision is paramount, such as financial transactions or security-sensitive APIs. Python code example, token bucket. Explanation asterisk. Asterisk the token bucket class encapsulates the rate limiting logic. Asterisk capacity is the maximum number of tokens the bucket can hold. Asterisk refill underscore rate determines how quickly tokens are added back to the bucket. Asterisk consume attempts to take tokens from the bucket. If there are enough tokens, it succeeds, otherwise, it fails. Asterisk underscore refill adds tokens back to the bucket based on the elapsed time and the refill rate. It ensures the number of tokens doesn't exceed the capacity. Asterisk threading. Lock makes the bucket thread safe, allowing it to be used concurrently by multiple threads or processes. 2. Identify users/clients accurately. You need a reliable way to identify the users or clients making requests to your API. Common methods include asterisk API keys asterisk assign a unique key to each user or application that needs to access your API. The key is included in the request header or query parameters. Asterisk authentication tokens, JWTs. After a user authenticates, you issue them a JSON web token, JWT. The JWT contains user information and is used for subsequent requests. Asterisk IP addresses asterisk you can use IP addresses to identify clients, but this is less reliable because IP addresses can change, especially for mobile users, and may be shared by multiple users behind a NAT, network address translation. Asterisk user IDs, after authentication once a user is authenticated, you can use their unique user ID. Python example, API key authentication. Explanation asterisk. Asterisk the require underscore API underscore key decorator checks for the presence of an XAPI key header. Asterisk it validates the API key against a dictionary. In a real application, you'd likely use a database. Asterisk if the key is valid, it passes the associated user ID to the root handler. Asterisk if the key is missing or invalid, it returns a 401 unauthorized error. 3. Define clear rate limit policies. Clearly define your rate limit policies and make them easily accessible to your users. Consider these aspects. Asterisk rate limit values asterisk specify the maximum number of requests allowed within a given time period, example 100 requests per minute, 1000 requests per day. Asterisk scope asterisk define the scope of the rate limit. Is it per user, per API key, per IP address, or per a combination of factors? Asterisk endpoints asterisk you might apply different rate limits to different API endpoints. For example, a high-volume data retrieval endpoint might have a stricter rate limit than a less frequently used administrative endpoint. Asterisk tiered limits asterisk offer different rate limits based on subscription plans. For example, asterisk free tier, 100 requests per hour. Asterisk basic tier, 1000 requests per hour. Asterisk premium tier, 10,000 requests per hour. Example policy documentation, conceptual. 4. Provide informative error responses. When a client exceeds the rate limit, return a meaningful error response. The standard HTTP status code for this is 429. Too many requests. In addition to the status code, include informative headers to help the client understand the rate limits and when they can try again. *X ROTA limit, the maximum number of requests allowed in the current time window. *X ROTA limit remaining, the number of requests remaining in the current time window. *X ROTA limit reset, the time, in seconds or a timestamp, when the rate limit will be reset. *retry after, the number of seconds the client should wait before retrying the request. This header is particularly important. Python example, Flask with rate limit headers. Explanation ***. The code maintains a dictionary requests to track API requests per API key. It checks if the number of requests within the last minute exceeds the rate_limit. If the limit is exceeded, it returns a 429 too many requests error with the appropriate headers. The retry after header is calculated dynamically to tell the client when to retry. 5. Use a distributed rate limiting system. For large-scale APIs, a single in-memory rate limiter on one server is not sufficient. You need a distributed rate limiting system that can handle traffic from multiple servers and ensure consistent rate limits across your entire infrastructure. Common options for distributed rate limiting include Redis an in-memory data store that's excellent for caching and real-time data management. It can be used to store rate limit counters and perform atomic operations to increment and check limits. MEMC8 another in-memory caching system that can be used for rate limiting. Dedicated rate limiting services services like Kong, TYK, or APG provide API gateways with built-in rate limiting capabilities. Database you can use a relational database, like PostgreSQL or MySQL, to store rate limit information, but this can be slower than in-memory solutions. Python example, Redis-based rate limiting, conceptual. Explanation ***. The code uses Redis to store a sorted set, JIT, for each API key. The JIT contains timestamps of the requests. It removes timestamps older than the current minute from the JIT. It checks the number of elements in the JIT to see if the rate limit is exceeded. If the limit is not exceeded, it adds the current timestamp to the JIT. The expire command sets a time to live for the key, so it automatically expires after the rate limit window. 6. Consider different rate limits for different operations. Not all API endpoints or operations are created equal. Some might be more resource-intensive or critical than others. Tailor your rate limits to the specific characteristics of each endpoint. Read operations versus write operations. You might allow more read requests than write requests. Public versus authenticated endpoints. Public, unauthenticated, endpoints might have stricter rate limits than authenticated endpoints. Complex queries. Endpoints that perform complex database queries or computations might have lower rate limits. Batch operations. Batch operations, example creating multiple resources in a single request, might have stricter limits. Example, conceptual, using Flask and different rate limit tiers. Explanation Rate_limits is a dictionary that defines rate limits for different tiers and endpoints. *User_tiers maps users to tiers. The rate_limit decorator retrieves the appropriate rate limit based on the user's tier and the requested endpoint. 7. Monitor and adjust your rate limits. Rate limits aren't static. You should continuously monitor your API usage patterns and adjust your rate limits as needed. Key metrics to track include *API request volume * track the number of requests made to each endpoint over time. *rate limit errors, 429s monitor the number of rate limit errors. A high number of 429 errors might indicate that your rate limits are too restrictive or that users are having legitimate reasons to exceed the limits. *API latency * measure the time it takes to respond to API requests. If your API is becoming slow, it might be a sign that your rate limits are not aggressive enough. *resource utilization * monitor the CPU, memory, and network usage of your API servers. *user feedback * listen to user feedback about rate limits. If users are constantly complaining about being rate limited, it might be a sign that you need to adjust your policies. Tools for monitoring **** Cloud provider monitoring *** AWS CloudWatch, Google Cloud Monitoring, Azure Monitor. *** Application Performance Monitoring, APM New Relic, Datadog, Dynatrace. ** Log Aggregation ** Elk Stack, Elasticsearch, Logstash, Kibana, Splunk. Example, Conceptual Monitoring, Simplified. Key takeaways. * rate limiting is essential for API health, stability, and fairness. * choose the right rate limiting algorithm based on your needs. * identify users accurately, API keys, tokens, etc. * clearly define your rate limit policies. * provide informative error responses with retry after headers. * use a distributed rate limiting system for scalability. * tailor rate limits to different operations and endpoints. * monitor your API usage and adjust rate limits as needed. By following these best practices, you can create robust and reliable APIs that provide a great experience for your users while protecting your infrastructure. Remember to choose the right tools and algorithms for your specific needs and continuously monitor your API to ensure optimal performance and fairness.